CNT125, we're continuing our review of Chapter 10. We're on the section where we're going to talk IDS as well as IPS. Your intrusion detection system, this is a standalone device or an application that's designed to monitor network traffic and generate an alert about, hey, something suspicious is going on, you might want to check into it. Your router access list or firewall acts like a bouncer who checks ID and only lets club members enter the door, if you will. So there is kind of like a yes or no. Yes, if you're doing this, you're allowed in. No, if you're that, no, get out of here. IDS is similar to security personnel sitting in a private room, monitoring the closed circuit camera and giving the security personnel alert. Hey, there's something suspicious going on over there. Go check it out. That's all it's really doing. So it's there to help gather and inform. So if I take a look at a network map, an intrusion detection system might be sitting back here. Basically almost like another node off of the switch that maybe servers are connected to or out where the client devices are, that sort of thing. And it's there to kind of watch traffic and alert you if something seems out of the ordinary. They use two primary methods for detecting threats, statistical anomaly or signature-based detection. Your statistical anomaly is going to compare network traffic to a predetermined baseline and go, hey, this seems out of normal for today. This seems out of normal. There seems to be a lot more of this thing going on. And again, that might be traffic from streaming, that might be traffic from games, that sort of thing. Your signature base looks for identifiable patterns or signatures that don't indicate specific vulnerabilities. So this now, I'm looking at, hey, does this seem like a normal, batch of traffic? Yeah, it does. Or no, this does not seem like a normal batch of traffic of, the kind of traffic we would have: email, web data, video streams, that sort of thing. This seems out of the ordinary. Something in here is not normal. You can have IDS as either as host-based or network-based. So your host-based, again, runs on a single computer, detect attacks on that host, insecure app running on a server, repeat attempts to log in, and it might include file integrity monitoring, alerts the system any changes made to files that shouldn't change, and that would be a host-based one. A network-based protects the entire network, looking at traffic network-wise, if you will. Usually situated at the edge of the network. Again, like I showed you in there, almost like an extra node in that part of the network. And again, it can detect many types of specific traffic patterns, like a denial of service type attack. Your network intrusion detection is going to sit at the side of, and it's going to be sending duplicate packets through port mirroring. Hopefully you remember that from our IP phone lab. We did port mirroring to be able to capture the IP phone packets. So your IDS would be doing the same thing. It's going to get a copy of all this traffic, pretty much everybody's traffic, and look for anything out of the ordinary. And again, it'd be sitting over here and alerting you as to this is out of the ordinary traffic. One drawback is the number of false positives. It can actually think that, hey, this looks like malicious data, but it's really just a couple of people signed on to a video stream to watch a product launch. That could be all it is. But again, all of a sudden it's a spike in traffic going to a couple nodes. It'll need to be customized, it'll need to be updated, it'll need to be evaluated regularly to make sure that it's tuned to detect what you want. It can actually be a hardware device that you're running in a network, in a rack, and so forth, or it could actually be on software on a system. Okay, so there's a couple different options there. Your intrusion protection system, instead of just alerting, it's going to try to react to. So where the IDS would give you an alert, the IPS is going to try to step in and go try to do something to change that, maybe prevent that. So to detect the threat and try to prevent the traffic from flowing based on the IP address and information that's plugged into it. So here, it's actually sitting in the network and the pathway, and again, if it'll detect anything malicious, it tries to block going to that node or that utility, if you will. And again, a reminder: ACL firewall, bouncer, checking at the door. IDS is your closed circuit television watching and looking for suspicious activity, and your IPS is literally a security personnel walking around, kind of right there to, hey, this looks suspicious, we're walking you out of here, you don't belong here. They were more designed as a comprehensive traffic analysis protection tool than firewalls. Firewalls have evolved, and the difference between a firewall and IPS have diminished in some cases. In some cases, they're almost the same thing, or the firewall has it included in it to respond to. Example, again, it's going to stay in line with the network traffic. Detect the hackers attempt to flood the network with traffic and can prevent that and literally respond to that and go, no, your traffic is not allowed through anymore. And valid traffic would be allowed through. And then that log would need to be checked and evaluated and maybe restated or etc. There can be a network-based intrusion protection or a host-based intrusion protection. Okay, here's your network-based, and you could also have a host running here as well. Again, the same idea, kind of capturing everything, logging it all. Can be a hardware device, can be software device, or software running on a system. They mention honeypots in here, honeypots and honeynets. A honeypot is basically a system purposely designed to be vulnerable, and the idea is you're watching it to see what the hackers do to it. And with that, you might gain knowledge of, okay, they try to access this way, let's try to find a way to start blocking that or filtering that, etc. There's number of different honeypot softwares out there that could be used. This leads us into device hardening. What are some things we can do to try to minimize? We're trying to make our target smaller. We're trying to make the target smaller for hackers. Make it less appealing, make it smaller, make it harder for them to get a hold of anything or compromise anything. So device hardening, what steps are we going to do to secure a device from network or software supported attacks? And again, if you haven't heard before, security is like a multi-layer sandwich. There's many different things that are going to get done. As we start doing our labs in chapter 10, 11 here, shutting off ports that aren't being used, using secure protocols, filtering traffic on certain VLANs, as things are moving through, and then doing these kinds of things here that we're going to be talking about as well. Multiple layers of things. Updates and security patches, yes. Our operating systems need to be updated, and with that, checking to make sure that it's still functioning as we need it to. I'm sure at one point or another you've done an update and it caused a problem on your system and you had to fix it. Well, in a company, you would need to maybe check it before you deploy it to everybody, find out what the update did. Is it fixing what we needed to, or did it cause a problem? And then what might I need to change before I deploy it to the whole company, to all 50, 100, or 1,000 computers in your facility. And then patches. Security gaps are often addressed in smaller, more frequent updates. And these might be like, okay, this is to patch this particular backdoor, this particular vulnerability. And again, that would need to be tested before it's deployed to everybody. Is it fixing what we need? Your process here of properly managing and applying security patches includes the following, kind of the steps that you would go through here. First, discovering what do we find that is a vulnerability, documentation. Maybe I see something's out there as a vulnerability, but you look at it and you're like, we don't run that software, we don't run that version, we don't run that update. So documentation can be the key to helping you know whether it applies to you or not. Standardization, having standard operating systems across the company with your systems, all running Windows 10 blah, Windows 11 blah, minimizes the headache of trying to get everybody up on or having that patch applied to block that issue. So having things standardized across can help with minimizing that issue. Depth of defense, applying multiple layers of defense, like we said before, shutting off ports, putting users in VLANs, putting them in subnets, filtering the subnets, doing the access list, having your intrusion detection, having your intrusion prevention system, plus doing these kinds of things that we're talking about now. Vulnerability reporting, identifying prioritizing relevant security issues. Again, you might have one person doing this, or it might be a couple people doing this in a facility. What vulnerability is out there? Does it affect us? What's our game plan to try to fix this? And when are we going to deploy it? When do we need to deploy it? When are we going to deploy it? And then implementation. How are we going to go about doing this? We probably want to test it on a machine and make sure everything functions correctly. We don't cause future, additional problems. And then again, how are we going to do that? And how are we going to communicate to people to, on Friday, shut down your machine or reboot your machine or leave your machine on and we'll reboot it for you. What are you going to do to make sure that this update gets out to everybody? And maybe you do it in groups. Try one group, no issues. Okay, now we'll deploy it to everybody else, kind of thing. An assessment. All right, did it do what we needed to do? And has it fixed what we needed to? Do we need to roll anything back? Do we need to change anything? But keeping documentation of that as well. That got applied. Everything worked okay. And then looking down the road, what kind of risks can we minimize by doing blah in the future? What can we do to lessen this? Maybe you discover that your company has operating systems that are kind of like all over the board, different versions, and maybe the plan is okay. In the next few months, where you're going to be replacing or updating all computers to blah 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 operating system using blah blah blah. And again, you need to do research to know, will it affect any of these systems? Maybe one department is using an older version of Windows because the new edition of software doesn't work on Windows 11 yet, kind of thing. So trying to figure out what do we do to get everything up to a certain base level, if you will. Firmware updates. Don't forget routers, switches, those sorts of things, firewalls all run on firmware. And from time to time, they are going to need to be updated as well. So a planned outage to do that, or maybe you're buying a newer firewall and you're getting it configured and ready that you can swap it out because it has the newer firmware on. But you can't just ignore it and be like, it'll be all right. Sometimes those firmwares can be a vulnerability as well in a company. Insecure protocols, we've mentioned before, we'll mention again. Phasing out things like FTP, using a secure FTP if that's needed. Again, phasing out Telnet, hopefully we're not using that, but using things like SSH, but maybe limiting where it can actually be used. Maybe the specific subnet. To protect devices, use these guidelines. These are a bunch of different things that can be done to protect devices. And I think I'd go through these and break each one of these out real quick. Reduce access paths. Shut off things that aren't needed. If things don't need Wi-Fi or Bluetooth, shut them off. Disable those if they're not needed on a system. Again, choose secure protocols. Only allow SSH. Block all the other ones right at the desktop. Don't let them get even used. And then only have the SSH filter that's only allowed to go to the subnet or the location it needs to go to. Reduce startup process. A lot of times your computers boot up and all kinds of things start. Maybe you get rid of some of those processes and only boot up what you need, so those things are not running in the background. Disable unneeded service as well. Maybe uninstall certain things that aren't actually needed. Disable them or uninstall them. Sometimes that is helpful as well. Yeah, declutter software, yeah. Disable or uninstall applications no longer needed. Again, because they would be running ports and things in the background and communicating traffic. Remove network segments that are no longer needed or subnets that are no longer needed. Close unused ports on devices and servers and so forth. Absolutely. Make sure it's a port that's not needed for anything. That would be a kind of like a committee process, if you will, and then close that down or filter that. On the administrative credential end, obviously we want to make sure we get rid of default username and default password and make sure we're using strong username and passwords. But with that, minimizing what you're able to have access to. Using SSH keys is more secure than passwords. Okay. The authentication credentials should be changed from time to time, obviously away from default, but also from time to time as well. And then here, these sorts of things, we started to mention this earlier. Any sort of account should have these kind of things on it. What are you allowed to do? Minimize that to just the basics. Where you're allowed to do this from or at, minimize that to just the basics. How long you're able to do it on, maybe just for the time frame they're working on the project or the amount of time they would be working on it. and then limit what they actually have access to. That would actually be helpful along with privacy. All right, we will pick up on the next podcast, and I'll kind of refresh these before we move on.